Hi and welcome to my new show. I haven't decided what to call it yet, but I'm sure I'll come up with a name. Right, I'm not going to waste any time. I'm going to jump straight in on this one. As you can tell by the title, it's about basically a theory of a new model of the atom, and it explains the exchange of energy and why we see certain patterns in nature that isn't necessarily explained that well. It's not in the social narrative anyway. Um, so Here we have what is current model of the atom. Looks like that bonded material in the middle, protons, electrons, whatever. So here we have what I consider to be the beginning. So at the time of the Big Bang, what we had is these. So that's antimatter, fermion, and boson. Now I'm talking of fermion and boson in the terms of positive and negative. It's not what science necessarily calls boson. They think it's something different. But as you'll see as we go later on, that's not necessarily the case. So we'll just call it positive and negative for meanwhile. So now if we see here, we've got the antimatter in the centre, the positive and negative. Now these matter is repulsed by antimatter, so these are pushed out and it's swelling this cell right out. So the contents doesn't actually go into it, the antimatter pushes it out, so it's up against the shell. So these are rolling about, there's no directional force actually on this material, which is why, even though it is such weak and light structure, that it actually contains the really quite violent reaction, I guess. So now, Big Bang, boom, happens. These things get voided. Some have like voided more fermion than boson, or some have voided, the entire contents completely, and then as they shrink down. In the absence of the antimatter pushing that matter outwards, they shrink down to the size of a neutrino shell. Now, this is what I think is more likely what's going on with the atom. So here we have again the antimatter, the positive and negative, the fermion and the boson, and I consider an electron to be positive, not negative. I don't understand why it's seen as a negative, sorry. But in this case, positive and negative, fermion positive, boson negative. Now, as we see, we have these electrons, which are basically just fermions filled up in neutrino shells coming from a reaction, which I'll show you in a second. And as say an atom, like we're born with inside our bodies are born inside a boson field. So as they're developed inside a boson field, they don't necessarily require protons to balance it out. So what they do is they just borrow the protons, the bosons from the boson field to act as the protons to balance it out. So there will always be the same amount of, say, fermions inside the nuclei as there is in the equal amount of electrons that surround it. I presume there's a limit to how many fermions can be filled in an electron. I'm not too. I haven't got too much in depth to it, to be honest. I think the key to seeing this is in its simplicity. Now we go to the reaction. So we see this in nature. We see it in snowflakes. We see the hexagon in say the granite pillars or basalt, whatever it is, pillars of what's it called, the Giant's Causeway. And we can see it in lots of things in the lens of a camera, but the most importantly, we can see it in the flash of a gun. Now, if you ever watched an action movie, which I'm sure you have, I've seen a few of them myself, and if you pause it just at the right time, as you see in the front of the barrel as the gun goes off, you'll see that there are 6 jets of flames, as it were, and 6 spaces with nothing. Now, under that extreme pressure, you think nothing can be able to separate. Everything would be mixed. But no, that's not the case. And that actually comes from the shells being destroyed that contain all these bits and bobs. And once they're set free, they're released. They actually repel each other because they're not held in by this cage anymore. They're set free, and when they do, they repel each other. So what happens is, now these are atoms, say, in an atmosphere, and they're hanging around, and then suddenly these waves come along, and now these things are designed to keep them in, fermions, which are just waves, but they're also designed to keep them out as well. So when they bang into them, they actually shake them about, and when they get shaken about, those things that are rolling around in the centre ain't rolling around no more. They're going like this. which essentially is like a big salt shake. You know, they're shaking out all these tiny little particles, fermions and bosons, as these waves are hitting them. The area's being resonated, and then they naturally divide themselves into what was positive and negative, basically fermion and boson, and that's where this little beauty is created. Now, there's a point of singularity where when they balance themselves out, there will be a point that the intersection where it all sort of the moment correlates, whatever you'd like to call it. Now you've got these violent jets of fermions shooting out, and then you've got bosons which naturally join the boson field because they're bond together. So just as fermions bond together, bosons bond together. So they actually join the boson field. But before that happens, they and then well, a quantity of them are individually changed into, well, I'll say individually, the vortices created by this moment. So this is rolling this way, and as you can see, the jet is causing another one. And what's going on is now there's neutrinos everywhere. They say 50,000 of them will go through your thumb at any one time. That's how many of them they are. Now, when this moment happens, these are all there, passing by. Now, the vortices, from the moment, the vortices fill these neutrino shells up with different quantities of fermion or boson, positive or negative. So now this is the electron up on the positive side, yeah, and that's rotating that way, and that's getting filled up. We want to 100% pure fermion. So that's why we use electrons for whatever, to power things, yeah, because they, you know, positive power, blah blah blah. But also you get these little runoffs. Now these runoffs, like vortices, there's another one there and another one there, and they get filled up with different levels of, say, fermion or boson, whether they might, I don't know, they might just be pure fermion. I have no idea, to be honest, in that depth. But so here we see, like, so you've got the electron at the front, and then you've got the proton at the bottom. Now scientists can currently see they say there's 6 leptons, was it 6 gluons, and 6 bosons. And from here, these are what they consider to be the bosons. Now they've found 5, but they're looking for the 6th. They say no, they think it's nowhere to say 666, yeah. And there's the boson, but they can't find it because I think they judge, perhaps maybe they judge bosons from a reaction from the fermions or something. I have no idea how they measure it per se, but so this is the missing boson from the reaction. So like things happen on a plane. So like you know, you see a snowflake that's flat, that happens on a plane, and this is the thing that creates it. So as fermions are shooting out that jet, water is H2O is basically 2 hydrogen, 2 oxygen. So it's basically 2 fermion, 2 boson, because a hydrogen atom is all fermions, but still with the antimatter, it's a nuclear center to make it a nuclei. And this is responsible for these different particles that are coming out of this moment. And when they collide these things together, and they think they're finding these particles inside, they're not. They're creating this electric moment that basically creates these vortices which fill up different neutrinos that are passing through with different quantities of fermion and boson. But now this is an interesting one. So a black hole, the way a black hole works is it doesn't destroy anything. It actually crushes everything down to its constituent parts, and it releases it of its bonding. So this positive end, we've got the centre of every galaxy. Obviously, you've got a supermassive black hole, and at the centre of that black hole, there's a beam of radiation that's been recorded. Now, that beam of radiation is fermion and boson. They're not usually together. They push each other apart. But it's rightly so, because if they didn't, they'd be tearing big. They'd be like lasers tearing big cuts through the universe, basically. But as they're fermion and boson, eventually they dissipate because they push each other apart. But out there, so you've got antimatter and matter released. So as the massive repulsion force between matter and antimatter shoots the fermion and boson, the matter, out the positive end, and out the negative end, what we call antimatter, which is, I think, what they call dark energy. Now, during the Big Bang, you know, I was saying about lots of these things get voided completely, and some have, you know, well, when they get voided completely, say, now the fermions will shoot off in forms of waves, in forms of radiation, but the bosons all hang around in a clump together. Now these things are floating through space. Now scientists think these are dark matter. Well, this is what dark matter is, I think. I don't think scientists are cottoned on. They don't know what dark matter is. But I think it's just bosons all clumped together in space in the absence of fermions. Now, you know, here we can see like a snowflake has that thing there. So, two hydrogen, two oxygen. So these ice crystals, when this moment happens, the fermions in them pull those atoms into that trajectory where it is with the bonding force of fermions and other fermions. Now here we see the gun flash, which is how the hell could anything separate under those conditions? There's intense pressure in that gun barrel as that thing goes off. There should be nothing separating, yet there is. A giant's causeway creates the hexagon, eyes of a fly, you know, the scales of a snake, you know, sunbeams, you know, the list goes on and on. But what I found quite interesting is I've come across a pattern which seems to represent everything that I've just said. Now, this little pattern here, you see X marks the spot, X marks the spot, X marks the spot, and we have these moments, these vortices that are filling out neutrinos, and it's all represented here. Now, if you're familiar with vortex mathematics, you can see that these shapes that appear, I think that's quite familiar to everybody. You know, the Star of David, you can see quite clearly, and there the hexagon at the centre. But I mean, that basically to me explains the exchange of energy and what's happening. You know, the frequencies in any given moment release fermions and bosons alike, and then they separate themselves accordingly. And then the reaction is we get these vortices. Now these ones, like I say, are spinning that way, spinning that way. I think they say the only difference between a fermion and a boson is half integer spin. I'm not necessarily sure what that means, but in an essence, it's got to be opposite, isn't it? They're fermion and boson, so it's plus and minus, positive and negative. But we can also see this in things like, so the graphene sheet test. I don't know if you've ever seen this, the slot test, where they say they were shooting some electrons through these gaps in a graphene sheet and they were hitting all the right places, but they turn up the wattage, and then this happened. You get 6 areas where they hit and 6 areas where they don't, and that's because the fermion and the boson are separated by the reaction. They're all getting freed from their containment, and as such they're organising themselves accordingly into equal parts. And there you go, there's the reason why the slot test gives that result. So this is the way I see the universe. Life inside life inside life, subatomic, atomic, astronomic. And so in atomic you have opposites repel. So fermion and boson, they repel each other, as we can see with the slot test, blah blah blah. Atomic opposites attract, so we've got the electric and electromagnetic where opposites attract, and then we go to astronomic, and then we've got matter and antimatter, so attraction and repulsion. And I think without opposing states of attraction and repulsion, you couldn't really have 3 dimensions, or whatever you'd like to call it, of space. So then we got, we think about it, solid. When the fermions are contained, they have a great bonding effect. The more electrons, the more bonding, or whatever. So you think acid and alkali, the positive and negative. But if you think of it in a state of a solid liquid gas, now water, 2 hydrogen, 2 oxygen, bang in the middle. Hydrogen, pure fermions, bosons, got lost there. Oh, never mind, you can see what's going on anyway, can't you? Acid, pH, neutral, you've got the mineral, you've got the acid and the alkali, the positive and the negative. It's all positive and negative. Hopefully it's a bit more positive than negative, but that's not the way that life works. Anyway, there we go, blah 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 blah. Well, we see we have going on. Oh yeah, the centre of the Earth. Now the neutrinos can't actually permeate all the way down to the centre of the Earth, which is the reason why they've got an underground facility that studies neutrinos. And they're right down there, really hot temperatures, right down into the Earth. But they've done that because there's less neutrinos coming down, so they can have a little gander at them. But maybe if they'd thought a bit more about it, they wouldn't have needed to spend all that money. So at the centre of the Earth, without in the absence basically of neutrinos, when decaying matter can't be contained. So all that in the middle is decayed away or whatever, and there's been no neutrinos there to capture the fermions to um, contain the reaction. So that's why we've got centre of the Earth is molten, and it's good for us though, really, because then that creates the ionosphere, because the bosons that are displaced from the centre are then pushed away, and they are spinning around, protecting us from solar radiation or solar fermions. Very similar, see the very similar, see the yin and yang and the model of the atom. It's led me to believe that this information has actually been out there for a long, long time, a lot longer than you might think. There we go, the sun. So now the sun's pure fermions, which is why scientists think that hydrogen is, is why they think the sun's made of hydrogen, even though it's a highly combustible material. Duh. That doesn't make fucking sense at all, does it? It's ridiculous. But anyway, so the sun's getting spun around on a spiral galaxy, spinning around, and it comes into cloud. It comes into contact with clouds in its path of dust and whatever. Now, if the attraction rate is greater than the repulsion rate, that cloud will get pulled in, regardless of the fact that it may be full of tons of bosons. And when it gets pulled into the centre of the sun, and those shells are destroyed, and then the fermions and the bosons seek to get further away from each other as they possibly can, a massive ejection of fermions is shot out with the bosons, and that's what solar flares are basically. So it all fits in now. Is there anything else sort of going on here? Yeah, these are similar things. See, look. So this looks to me like to be the forces of a galaxy. So we've got the black hole at the centre, gravitational waves in space, the beam that scientists have discovered comes out of the centre of the black hole, and the inevitable swirling of the universe. And then you've got this little line here, which is apparently the veil of the abyss. So if you go outside the galaxy, where there are no neutrinos, there'd be no propulsion, because you have nothing to push off of. So essentially, if you resonate gold in the atmosphere, in space, it should actually provide you with propulsion, because it's pure fermions captured at the point of a supernova, where they've gone super hot and dense out into the freezing cold in just seconds. So this looks, and I don't know how long this has been around, but I see it all the time, like wands of the gods or whatever, and you know. Now, what I think is going on with the antimatter is, say, if functionally speaking, like neutrinos stop the universe from going into fission, I think antimatter actually stops galaxies from bumping into each other, because although they're full of like fermions or whatever, they've got an attraction, so it's possible they might get, even though they're shooting away from each other at a great speed, it still might change the trajectory or whatever. So I think these black spots that we can see in space sometimes, they don't understand. Maybe it may just be bosons that are clumped together that fermions can't pass through, so they look like big black holes. But I don't think that black holes can exist outside of a centre of a galaxy, to be honest. It just doesn't make sense to me. Anyway, that's my theory. Let me know in the comments section if what you think about it. It'd be great to hear. Especially from a scientific point of view. Obviously, what I've just said, you'd be picking bits out of all day long, but currently science doesn't understand a lot of things, and that's just explained them. So, keep an open mind. Alright, thanks for watching. Bye.